Okay, so our next question is automorphic number. Now a number is called an automorphic number if and only if its square ends in the same digits as the number itself. Now to explain you more about this, let me delete the title, and let's say we have given a number 25. So what will be the square of it? So 25 square is 625, and as you can notice here, the number is ending with the original number itself. So this is an automorphic number. Then let's say we have a number 76. So 76 square is 5776. So it is ending with 76. Then we have 11. So 11 square is 121, but it is not ending with any 11 number here. Okay, so this is not an automorphic number. So the logic behind this is what we need to do. The step one will be calculate the square. That is the very basic step. And let's say we have taken the example of 25. So n equal to 25 here, and the square number will be 625. Okay, now the logic behind this is what we can do, and as I told you in various digits and numbers related problem, then we can access digits of a number individually using the modulo operator and the divide operator. Like, so let's say we have taken this 25, we divided it by 10. So this is the modulo operator, and it will give the remainder, that is the last digit of a number. So in this case we will get 5. Okay, and when we will divide the same by the squared number, we will get the 5. Okay, now what we will do, we will check if the number is equal to the given number or not. Okay, given number or calculated number. So if both the digits are same, then we are good to go. What we will do, we will reduce the number. So this 25, what we will do, the next step is 25 by 10. So this will give the number 2. Okay, and this 625 by 10 will give the number 62. Okay, now what we will check, if my given number, that is 2 %10, it will give the digit 2 here, and this 62 divided by 10, that is modulo operator, it will give the 2. Okay, and we will check if the number is equal to original, that is calculated number, or not. If it is there, then we are also good to go. We don't have any problem with that because the number is, getting equaled. What is this word? So it is getting equal. Okay, now after that the number will reduce to 0. 2 by 10 will be 0. Okay, and our work is done here. So when the number is getting reduced, and we will check the flag, if the flag is not set to 1. So let's say we have taken example of 121. So at any point of time, the equality that we are checking, it becomes not equal, then we can simply set the flag to 0. If it is 0, then we can set flag to 1, and we can break out of the loop, because we know that the numbers are not equal at certain point of time. So we don't want to check. I hope you got the logic. Then we can simply check at last if flag is equal to the 0, that is the previously set, or not. If it is 0, then the number is automorphic number. Okay, else it's not automorphic. I don't know the spelling. Else it's not. Okay, now let's write the pseudocode here. We have a number 76, let's say 76, and we have a initial flag to 0, because we need to check whether all the numbers are equal or not. And at certain point of time, if it is not equal, the digits are not equal, then we can set the flag to 0. So let's set the flag to 0 first, and then we can set to 1. Okay, so this 0 means basically the number is automorphic. Now what we will check, while our number, so what we will do first, we will calculate the squared number. So what I will do, I will delete this n, and we have number n equal to 76, and we have squared number, let's say sq equal to n into n, and this will calculate the number, and I will write the 5776 here. Okay, this is the square of a number 76. Now we can reduce the number. So while my n is greater than 0, okay, we don't need to check for a squared number, because it will be anyway greater than the original number, and the number will not be reduced at any point of time. Okay, now we have checked for 10, n is greater than 0, we got the digit. Okay, now what we will check, it digit underscore 1 is basically we are calculating the last digit of a number. So n% 10. Okay, this will give this 6 for the first time here, and we will grab the second digit. So a digit underscore second is equal to the squared number. We'll grab the last digit of a squared number, so square %10. After that we can simply reduce the number, that is n equal to n by 10 and square equal to square by 10. So this will get rid from the remainder and it will give the quotient. So remaining all the digits, all the numbers are there, it will go and give them to us. Now here what we can do, we can check if my digit underscore 1 is equal to my digit underscore 2. Okay, now if it is there, then we don't want to do anything. So what we can do, we can check for not equality. So let's say if at any point of time my digit 1 is not equal to digit 2, then we can simply set the flag to 1 and we can break out of the loop. Okay, now here simply what we can check, if my flag is still 0. If it is still 0, it is not been executed this this line of code, this block of code. That means that the number is an automorphic number. So we can simply print that the given number is an automorphic number. Okay, and else we can print that the number is not automorphic. Okay, so thanks for watching, and now let's try to incorporate this into actual code. Okay, let's do the code for automorphic number. So here I have declared a number and I will take the input from the user. After that we will need to calculate. Okay, so square, let me write something like int square of a number is equal to basically number into number. Okay, now in automorphic number we just need to check the last digit should be same of both the numbers, that is the original number and the square of a number. So here what I'm going to do, I'm just going to loop until my number is reduced to 0. So let's say if my number, or let's say my square number is reduced to 0, is greater than 0. So here what I will do, I will grab first digit 1. Let's say digit underscore 1 equal to, we will take the last digit of the number first. Okay, and after that we will have int digit 2. Okay, and here we can do something like square %10. Okay, after this we can reduce the number. So number will be equal to number by 10 and square will be equal to square by 10. Okay, this is the way in which you can do it. Now okay, cool. After this we just need to check whether digits are equal or not. So here what I will do, I will raise one flag, let's say boolean flag equal to true, which will indicate that the number is an automorphic number. So here we will check if at any point of time my digit underscore 1 is not equal to my digit underscore 2. So if this is the case, then I can directly say my flag equal to false and we can actually break from the loop, because we know that the number is not a automorphic number. So here I will check if my flag is equal to true. If this is the case, then I can directly print something like my number is an automorphic number. So if I write it like this, and in the else part we can directly say it's not a automorphic number. Now let's try to execute it. I will create a problem. Let's give input 25. 25 square is 625, and you will get something like, okay, in the else block we don't need to check anything. We will check else cout equal to is not an automorphic number. If you run it, it will give something like 0 is not an automorphic number. The number has been reduced to 0, so I can actually have the original number here. So let's say int original number, which will take the reference of the number that we have. So here we can directly print original. Okay, I think this condition is failing. So if you rerun it, you will get 25 is not an automorphic, but it's an automorphic number. Okay, I think we need to reduce the number first, because see, we know that this length of the square number will always be greater than length of the number. Okay, so we only need to check the digits of the number, that is original number that we have. Now this time it will definitely going to work. If you run it, it will give is an automorphic number. So if you give something like 76, okay, it will give 76 is an automorphic number, and because its square is 5776, and if you give something like 56, F56 is not an automorphic number, so it's working perfectly. Okay, now it's your time to do the code. Thanks for watching.